So this is part 227. Line 19a6a Binomial Coefficient Wolfram alpha x, and I think it's to the power of 0.3333. Gamma function equations UFO 5G Wow Seti. Whenever there's the UFO 5G, it talks about the UFO engine components or things that are used to power it or jet propulsions, okay? So there's the Wow Seti alien radio signal. There's the math equation with its answers. So we Google these numbers, and this is some of the keywords that come up. Wolfram Alpha Computational Knowledge Engine, and that came up on this site here, wolframalpha.com. So May 14, 2012. I'm currently filming this on June the 7th, 2012. So May 14, 2012, looking at the equation on Wolfram Alpha x to the power of 0.3333. I pick out the formulas that stand out here and have keywords in them. Visit the blog to see the others. So enter what you want to calculate or know about. Examples at random. So it has this number here, and it says graphs, plots, roots, series, expansion, derivative, integral, limit, max, minimum, refresh now. Input is x to that number. So this is the mathematical equation that goes with this particular number that comes up in the WOW alien signal. So NM is the binomial coefficient, Z is the absolute value of Z. So again, in earlier videos we have a binomial coefficient, we have N and M, we have Z, we have X to the power of 100, and this is obviously a mathematical equation you're going to have to use with your stuff. There's the integral representation, right there. Again, you can go to Wiki and see more of this. X is the gamma function. RZ is the real part of Z. RZ is the complex argument. E1, E2 is the logical end function. I is the imaginary unit. And that's at wolframalpha.com. Here's a graph. It says it is easy graphically to interpolate the factorial function to non-integer values, but is there a formula that describes the resulting curve? So it looks like they're looking for a gamma function formula here. May 14, 2012. So they're looking for a mathematical function to describe the resulting curve for x to the power of, I don't know if it's to the power of, that's what I'm saying because that's what I think it is. So if I got it wrong, I apologize. 0.3333 and gamma function being the keywords here. I have a feeling you will find this equation in line 19 of the WOW Seti data. I wonder who will figure it out first. Keywords from Wiki to look at here. Euler's reflection formula, the Gaussian integral, Laurent expansion, pi function. I'm going to search the notebook for it. It's not here as of 14th of May 2012, line 19. So as of that date, when I did the search, none of those words came up. So the Riemann zeta function on Wikidata to look at. Here's a graphic here. That's the Riemann zeta half plus IT. And it's got all these little numbers there. Here, we'll make it a little bit bigger for you. It still doesn't make the numbers bigger, unfortunately. Everything stays the same. So, you notice the circles though? Those came up earlier in the very beginning. That's something like a snail, like the universe, and it looks like an orbit as well. This image shows a plot of the Riemann zeta function along the critical lines for real values of OFT running from 0 to 34. The first 5 zeros in the critical strip are clearly visible as the place where the spirals pass through the origin. May 14th, 2012. My thoughts. Looking at the polar graph, the circles look like the orbits of planets to me. Google RE 1/2 plus IT. I did a Google search and Wolfram brings up some calculations for you to look at. Integral representations. There's the graph for that. I should have made it a little bit bigger. Yeah. This one makes it bigger. I get like that. And then this one here. Don't you just love OneNote? It's fun. It's great. Okay, so x is the gamma function. CHX is the hyperbolic cosecant function. Again, in earlier videos we have gamma rays and we have the hyperbolic is another keyword that comes with neutrinos. There was a formula that came up with the alien messages that had something to do with these two. So this is very an important function to remember. You're going to want to apply these equations to whatever it is that this is linked to. Okay? So these are the functional equations. And this one here. Should have done these earlier. I guess I thought they were big enough, but when you actually look at them, I don't have my glasses on. That's the reason why I can't see them. Little puny numbers. Okay, n is the factorial function. Nm is the binomial coefficient. And again, that's at wolframalpha.com. May 14th, my thoughts. I have several formula ideas coming to mind now. Here are the formula ideas based on the keywords found in the line 19's data. For the formula, you want to take hyperbolic plus x is gamma function plus chx cosecant function plus c times Schrödinger equation plus c equals circular detection probability times Schrödinger equation plus n factorial function plus n divided by m is the binomial coefficient plus isotropic quadratic form. So those are all the keywords. I put them together, and what we do is you try to put these things together and see what you get. Okay? I don't know what it will make. I have no idea. If this formula doesn't work, what you want to do is add other things to it. You want to try to get it to work. Okay? So use this formula to create a wind-powered vehicle that goes faster than wind. A quadratic rocket. So supposedly this equation here is going to help you with a quadratic rocket. That's why that's all together. So you want to take liquid argon gas or xenon as the ion source. You want to add GaAs solar cells or gallium arsenide solar cells plus a semiconductor plus heterostructures plus photovoltaic devices. Okay, so these are all the different keywords that came up in line 19, and if we add them all together, this is what we get for our formulas, okay? So you want to Google GaAs solar cells. I wanted to find out what it was. It says it's a gallium arsenide solar cell from photovoltaics.sandia.government. Influence of, so this is a PDF research. We get some research stuff here. So influence of volume dope on Fermi level positon at gallium arsenide surfaces by J. Van Laar and J. Scheer. It's from the Philips Research Laboratories in this place in the Netherlands. They received it, actually look at this, it was received in March 1967, which is just before our WOW signal. It was 10 years before it. And it became online in September 2002. So the abstract, photoelectric emission and contact potential measurements were performed on ultra-high vacuum cleaved GaAs single crystals of various doping levels. The measurements show clearly that there is no Fermi level stabilization at the surface by surface states. In fact, the Fermi level can be shifted over about 1 eV going from P to N type material. This effect is markedly different from the situation in semiconductors like Si and GE, where Fermi level pining is well established. That was from 1967. It was published by Elsevier BV in the www.sciencedirect.com website. So the next thing I'm going to do is Google photoelectric emission on line 19a6b. So that'll be the next video.